Hi YouTube people, I'm your teacher REGY SAFADÁO, and today we are going to solve two examples about the surface area of a triangle. Are you ready? So, come with me! Hi YouTube people, I'm very glad to have you here back with us in our class number 3 of 12. We are going to keep on talking about the analytic geometry. Today, I'm going to show you how to find the area, the surface area of a triangle. Let's see our opening. As you already know, our channel is Mathematics with Different Teachers, and here we have classes of physics, mathematics, and English in two versions, one in English and the other one in Portuguese. All right, go there and visit our video classes in Portuguese. They are really terrific. Okay, so finally, let's start. Okay, as I told you, analytic geometry, surface area of a triangle. Well, we are going to find it. I'm going to show you how to find this surface area through a methodology of Pierre-Sarrey. Okay, the rule of Pierre-Sarrey. Well, Pierre-Sarrey was an excellent mathematician, and he was born in 1798 and died in 1861. Well, to obtain the surface area of a triangle, knowing the coordinates of all its vertices in a Cartesian plane, we can use the rule of Sarrey for determinants. Okay, so given the points, let's see, A, B, and C. Okay, so A, we have the x of A, y of A, B, x of B, and the y of B, and C, x of C, and the y of C. So these are the coordinates of points A, B, and C. Now the Cartesian plane. Okay, x number line, y number line, point A, point B, and point C. Okay, so there is a triangle. Okay, when you get them together. Okay, so we have here a green triangle. Okay, now let's see the coordinates of point A, coordinates of point B, and the coordinates of point C. As I told you here on the left. Okay, so we have x of A, x of B, and x of C. And also y of A, y of B, and y of C. Okay, and the horizontal and on the vertical number lines. Okay, the surface area of a triangle is found by the equation. Okay, so the surface area of a triangle, just one second, let me get a laser pointer. Excellent. So the surface area of a triangle A, B, and C can be given by 1/2 times the modulus of the determinant. Okay, let's see this in two examples. Okay, so example A, calculate the area of the triangle defined by the points A, B, and C of the following figure in meters squared. Okay, so let's see the Cartesian plane here, x and y. And we have points A, B, and C. All right, and now we have a blue triangle. The coordinates of point A, the coordinates of point B, and also of point C. So let's show you. Okay, so 1, 3, and 4, and -1, 2, and 4 are the coordinates. So let's get all the red points. Okay, so 1 and 2 are the coordinates of point A, 3 and 4 are the coordinates of point B, and 4 and -1 are the coordinates of point C. Now, let me move my window. All right, so the surface area of the triangle A, B, and C is 1/2 times the modulus of the determinant. So let's find the determinant this way, applying the rule of Sarrey. All right, so see how we have to do. Let's find the determinant. Okay, let's see. So 1 and 2 are the coordinates of point A. You can see it here. 1 and 2. Now 3 and 4. You can see 3 and 4. And now 4 and -1. See, you can see how we can do it. Okay, we are organizing the determinant, and then we are going to apply the rule of Sahi and solve this. Now see what we have to do. We have to do a column of numbers 1. Okay, then we are going to repeat column, the first column 1, 3, and 4, and the second column 2, 4, and -1. Close the determinant. Okay, now we have 3 diagonals. 1, 4, and 1 is a main diagonal. 2, 1, and 4 is another diagonal. 1, 3, and -1 is another diagonal. We are going to multiply them. See what I'm going to do. The determinant is, okay, 2 parentheses and a negative sign between them. Okay, here we are going to write the following operation. So 1 times 4 is 4 times 1 is 4. Okay, this way you can see the ring, the green arrow here. So 1 times 4 and 4 times 1. Okay, so the result is gonna right there. Okay, so 4. Now see the other one. You see the arrow, the green arrow. 2 times 1 is 2, and 2 times 4 is 8. So it is here plus 8. And here 1 times 3 is 3, and 3 times -1 is -3. All right, you can see -3. Okay, so we did this. Now let's do the other multiplications here. This is another diagonal. This is another diagonal, and this is another diagonal. All right, now let's do plus times plus is plus. Okay, you can see here the red arrow. 2 times 3 is 6. 6 times 1 is 6. You can see plus 6. Now let's write the other the red arrow here. Well, plus times plus is plus, times minus is minus. So 1 times 1 times 1 is 1. So -1. Let's write there -1. And here 1 times 4 is 4. 4 times 4 is 16. Plus times plus times plus is plus. So plus 16. You can see? All right. Now, these first brackets here, okay, are going to be taken out. Like this. 4 plus 8 minus 3. Okay, now minus and plus is minus. Let's see. Okay, we have to do this. Minus and plus is minus. So here we have -6. You can see? And the other one, minus times minus is plus, like this. You can see? So we have +1. +1. And the next one, minus times plus is minus. So we have -16. You can see? Very good. Now, see what we are going to do. I use to organize the positive numbers together, like 4 plus 8 and +1. Like this, 4 plus 8 +1. And the negative, get them together. -3, -6, and -16 here. Now let's operate. 4 times 8 is 12. Times 1 is 13. So the determinant is 13 here. And -3 minus 6 minus 16 is -25. Now let's operate. 13 minus 25 is -12. So the determinant is -12. Now, to find the surface area, we have to do 1 times the modulus of the determinant divided by 2. Let's do it. Remember, the determinant is -12. So let's plug this value into that formula. So the surface area of A, B, and C is 1/2 times the modulus of negative 12. So it is 12 times 2. Sorry, 12 divided by 2. So the surface area is going to be 6 meters squared. Okay, so example one is done. Example A is done. We have finished this. Let's go to example B. Let's see. Okay, here it is. Determine the area in centimeters squared of the triangular region that has as vertices the points P, Q, and R. Okay, here we have the Cartesian plane with X number line and Y number line. Let's see the points. O, Q, R, and P. Okay. All right. Let's see. Oh, yes. We have here a yellow triangle. Let's see the coordinates. The coordinates are important. Coordinates of R, coordinates. Okay. So 0, 2, and 4. And there we have 3. So yes, the ordered pairs, okay, or the coordinates of P, Q, and R are of P 4 and 0, Q 0 and 0, and R the coordinates are 2 and 2. All right. So just 1 second. Let me move my window. Excellent. Okay, so the surface area of the triangle, in this case, P, Q, and R, okay, is 1/2 times the modulus of the determinant. Let's get the determinant, okay, by the rule of Sahi. Remember? So the determinants, let's organize this. So point P is 4 and 0. You can see 4 and 0. Point Q is 0 and 0. Good. And point R is 2 and 2. All right. And then right here, we write a column of numbers 1. You can see. Close it. Then we repeat column, the first column 4, 0, and 2, and then the second column 2, 2, and 0, and then we close the determinant. Remember, now we have the main diagonals. All right. See the determinant. Write 2 brackets, okay, and a negative sign between them. Okay, so to get these numbers here, we have to multiply. 4 times 0 is 0, times 1 is 0. Okay, like this, 0. And the other, 0 times 1 is 0, times 2 is 0. You can see? And the last one, you can see, 1 times 0 times 2 is 0. So the first one is all 0, 0, and 0. 0 plus 0 plus 0. And the other one, 0 times 0 is 0, times 1 is also 0. You can see? All right. And now, 4 times 1 is 4, times 2 is 8. And plus times plus times plus is plus. So here we have plus 8. You can see? Plus 8. And here, 1 times 0 is 0, times 2 is 0, so we have plus 0. You see? Excellent. Now, let's operate. So the determinant is 0 plus 0 plus 0, minus times plus is minus 0. Minus times plus is minus 8. And minus times plus is minus 0. Okay, now let's take off. Okay, let's cancel out, in fact. Let's cancel out all of those zeros, and the determinant is negative 8. Okay, so let's plug this value into that formula of the surface area, and so we have that the surface area of P, Q, and R is 1/2 times negative 8, modulus of the negative 8. So we have that the surface area of the triangle PQR is h/2, h divided by 2. So the surface area of the triangle PQR is 4 centimeters squared. Okay, thank you very much. all of you who watch our video classes until the end. It's quite very important for us. Subscribe to our channel, ring our bell, share our video to all of those people you love, okay? And give us your precious like. It is quite very important for us. I am your teacher, REGY SAFADÃO, talking to you from Brazil, all right? See you. Bye-bye. Have all of you an excellent week. Bye-bye.
That's all, folks.